Okay. Okay. Do you see my screen?
Yeah, it's good.
Very good. And now it's better?
Yep.
Okay, very good. So first of all, thank you for the invitation. I think my presentation will be more about our experience here in the UAE of building two models, LLMs. One in 2021, which was called Noor, which is an Arabic model called the large language model. And second, also the recent announcement that we made with what we call Falcon LLM, which is one of the biggest models now in standing. It's a which basically is a large language model at the same level as GPT-3. So, of course, I'm quite happy for the invitation you gave me, and I appreciate a lot the presentation that was made by my colleague before. I think these large language models, of course, are posing a lot of challenges on how education is made and other aspects of our life. But I think we need to think more about what it's bringing as an added value, of course, for our daily work. And I think the way I see things, and I think my colleague was mentioning it, is not about the answers basically that large language models provide, but mostly about how you question those answers. And I think if you had time to play with ChatGPT, you'll see that the key in all the results that you get is related to prompting. Prompting meaning basically how you prompt the machine to get your results. And depending on how you prompt the machine, you'll get different answers. But when you think it through, it's exactly the way we do our education and our daily life. In general, the most important thing in life is how you ask the question. If you're able to pose the problem nicely and ask the question nicely, then 95% of the solution is done. And I think all the graduates who are listening here know that. In general, what is the most important for you and which what takes time, even in a PhD or research, is to define the statement of your research. Once you define the statement of your research, then the solution basically is quite easy to done. It takes time, and of course, these tools that we're building today based on large language models are, of course, increasing your efficiency to get the results. However, the process of how you start prompting the machine or building your question, I think, will still remain. And I think the value that we're having here as a community and the teaching that we're giving will be mostly about helping people to pose rightly the problems, to define nicely the context of their problems, define nicely the question. And once you define precisely the question, you're able to basically give the answer and not at least forming problem solvers, but as I would say, problem prompting people. And I think this is the big change that I'm seeing today around those things. So this was just a comment that I wanted to make based on the presentation that was made before and how this, of course, will change the way, but it's not going to be changing the way in a bad manner. It's going to be changing the way things in a good manner by giving more power to the people in the sense of teaching them on how to reason before talking. Because once you do that, then of course things are fine. So as far as I'm concerned, I'm chief researcher at the Innovation Institute here in Abu Dhabi. I'm also professor at Centrale Superior, and I've been all my life at the interface of the ICT, working in tech, mostly 4G, 5G, 6G, and also basically AI. So before I start, I want to give a very good example, a bit of background on machine learning, just to understand how things have changed for what I call basically machine specific machine learning task to what's doing what I would say GPT or large language models in general are doing, which are multitasking. So here you have two pictures. One picture on the right is a
Sorry.
picture of a guy called,
Sorry. Now I just can see the first slide. It is not in
oh,
a present mode.
okay, you don't see it?
Uh, yeah, I just see the first slide.
Okay, let me share again. It's weird.
Yeah.
Okay. Do you see now the second slide?
Yeah, it's good now.
Okay, so if there's a problem, you tell me. So here, I want to show you basically this transition from what I call specific machine learning task to what we call large language model that can do multitasking. For the specific machine learning task, which was a big revolution a couple of years ago, I think you have here rapidly in 2 or 3 minutes the explanation. You have two pictures here. On the right, the picture of a guy called Newton, and on the left, basically what we call a ballistic kick. Now, if you're at high school at the beginning of university and they ask you to find basically the angle theta with which you can kick a ball for a given distance, then usually what you do as high school, you solve these Newton equations. And with Newton equation, you can find basically the theta angle. Now, suppose you don't have that Newton equation, what we call a model. Then how would you solve the problem of kicking a ball? Well, machine learning people and especially NLP people will tell you what you do is you generate a database where you put two columns. One column is the angle, the other column is distance, and you kick the ball like hell, many, many times. And by kicking the ball many times, you have, of course, many, many of those ranks of your column which are filled. And next time you're asked to kick the ball at, let's say, 100-meter, you will look if in your database 100-meter is there. And if it's there, then you find the angle and you solve the problem of kicking a ball. Has nothing to do with machine learning. It's called basically data mining. And still, you need to find very fast algorithms of search to do that. Where you could say that you're doing some kind of machine learning is when the distance is not in your database. So if the distance of 100 meters is not in your database, what will you do? Well, you will do some kind of interpolation. You will say, okay, I have 90 meters, I have 110 meters. 90 is the mean of these two. And then I can find the angle because the angle is also the mean of those angles, and I can find the angle. You will do what we call some function approximation. You will find the function that approximates x to theta. You will find basically how x equal f of theta or theta is equal f of x. And so this function approximation, quite outstandingly, we were able to find basically a neural network architecture which approximates that. And what you're going to do, you're going to train your data so that you can find that function, which is going to be approximated by hardware structure. And basically, you can solve after any of the problem of x's that I give you, and you'll find the thetas afterwards. And so this is very specific because you're only dealing with that structure, basically, of database, and it's very specifically tailored to that kind of task about how you relate x to theta. Of course, even in that realm, there's many caveats that are known in AI. The first one, which is known, is that, well, if you use the database and you trained your system when it was not windy, and you're asked to kick the ball because you're trained on a system which could not deal with that. So you need a lot of data to look at all the cases when there's a wind of 5 kilometers an hour, and a wind of 10 kilometers an hour, a wind of 15 kilometers an hour. Second thing also, which I went very fast, is that the input-output parameters are not clear for machine learning specific tasks. What I mean is that I went quite fast. I told you that there was a one-to-one mapping between x and theta. In fact, you need to know also the V0 that I'm putting there, which is called the initial speed. And so this is typically what you have when people apply AI for medicine. A doctor comes and tells you, oh, you have a column of people who have a cancer, and you have a column temperature. Now, I give you a new temperature. Can you tell me if a guy has a cancer? Well, obviously, you cannot relate temperature to cancer. The question is, what is the other columns that you need to put to find some kind of relations? So you're going to add a new column, which is maybe blood pressure. You're going to try to find some links. You're not able to find that. You're going to add another column, which is what is his fatherhood or whatever past he has. So that kind of data science work turns out to be extremely complicated to do because the input parameters of your model are not easy. And the third caveat that we know, and which is still not solvable, is how you generalize, in which basically today, a lot of the techniques that we're using in large language models are trying to find that, is of course that if you kick the ball as much as you want on Earth, you'll never know how to kick the ball on the moon based on these data-driven approaches. Okay? Next slide. Do you see this next slide, by the way? Just to be sure.
Yeah. It's
okay.
Good.
So we went from a very specific task where people were just solving one task. And we knew that when we solve one task, when we depart from that, we're not able to solve the other tasks. You remember when there are some wins, we're not able to cope with that. The question is how to build something that can be broad enough to do basically a variety of end tasks. And this is exactly what you're seeing today with these chat GPTs. So this notion came, of course, with some new architectures, which are based on what we call GPT, which is generative pre-trained transformer. It's not the only architecture you have to know in LLMs. You have other architectures which also enable you to do that. It's quite famous because OpenAI has been very present, but you have architectures called BERT, T5, which are also quite effective, which to do exactly the same kind of things. So LLM stands for large language models. GPT-3 and ChatGPT is based on that. And it's a type of machine learning model that uses natural language as input and output. And it's trained on a large amount of text data and can perform a larger variant end task. When we mean text data, it means also that you have other types of data, but you convert it into what we call some tokens, which are of the text type. So even if you give me some code, which is Python code, we will still be able to consider it as a language by making some routine on how to define a code as a language. And this is a bit of a work that people do in terms of how to convert that code into a language by doing some tokenization. But the idea is that you start with a lot of data that you need to do, on which you do some curation and processing. Then you extract from it some what we call broad, high quality data. So that takes a bit of work. And then you start using these architectures that I've been talking about, GPT or BERT, to do basically extreme scale training. In general, the training is not based on supervised learning. Supervised learning, as you all know, is based on the fact that you have people who label the data. When you have tons of data, it's not possible to have a supervisor behind. And so we have a technique called self-supervised learning, where you have only a subset which is labeled and the rest you don't need, and the system goes on. Otherwise, it's not possible to do that. And then you build up your foundational model, and based on that, you can refine it. And that's what we do based on specific use cases. And the majority of people now, what they're doing, they're taking these foundational models and then they do some adaptation of that to be able to focus only on computer vision, cybersecurity, proteins, stuff like that, where you will then train specifically to that kind of vertical or use case in which you're going to do. As a summary for that case, the idea is that you start building your LLM structure and then you put some text instructions, and then at the end you get the answer. So LLMs provide a universal text-based interface to tackle nearly any text. As I told you, at the end, what is the most important thing for you is how you prompt. What is the text instruction? And then I think you saw it. Depending on what are the texts that you put, you'll get a different answer. So you need to pose very nicely, basically, your question to get the answer. And sometimes to get, for example, the right image that you want, you can spend 80 hours prompting, checking, doing different things. So when people talk about creativity of ChatGPT and being the machine doing it, you have to know that any kind of nice picture, even the award-winning design that was made a couple of months ago and made the headlines of a picture which was awarded by an AI, the guy behind spent 80 hours prompting the machine. So he worked behind, because you need basically to ask the right things you want, to look, to rechange. It's not just a random prompting that you do. But in case these key aspects able to tackle broad tasks from just instruction, their capabilities increases as you scale up the size and compute. And you saw that moving from GPT-3 to GPT-4 in terms of number of parameters of the models made it extremely high in terms of capabilities. By the way, you have to know that whenever we talk about a model, the key feature of a model is not only the size of the parameters. So, for example, if you take GPT-3, which has 175 billion parameters, you take another large language model, which is called Chinchilla, which has roughly 70 billion parameters. The 70 billion does much better than the 175. Same thing as what Facebook released with Llama, which is roughly around 50 billion parameters. It does even better. And the reason is that we realize that it's not just about the size which matter. It's also about the data set that you're using, the quality of the data set, and also the amount of time that you spend training. The more you train, the better it is. So you need to play with these three factors, and you can come up with models of bigger size and still having a big impact. And of course, the applications are huge in our domain. So how does it work rapidly in a couple of seconds? And then I'll give you some examples on what we did. The whole idea about basically large language model is about predicting the next word. You provide a context, which is a question, and you need to provide the answer. So you need to define what is the probability of an answer given that context. So your goal basically is to find how you will learn a probability distribution based on a huge number of texts. So your idea is basically I will be learning this property distribution. How you learn is basically, of course, by mapping it into an architecture and learning the parameters of that architecture. And at the end, you'll be able to learn that property distribution. And anytime you have a context, you're able to predict the next word or the next text or the next page. Okay. And here, as an example, by a lot of text that I'm putting in where I will learn that property distribution, the next time when I put the capital of the United Arab Emirates is Abu, and I'm waiting for the answer in a prompt, well, basically the machine will tell me Dabi. And why? Because it learned on all the thing and is able to predict the next word based on that. Of course, all combinations are possible. I mean, you can also predict inside, outside, larger text. And this is exactly when you run these machines to be able to learn these property distributions that I was mentioning about. And of course, this biggest change was made to the fact that in terms of machine learning, well, we were able to have a lot of compute which was available. When you look at, I would say, before 2010, in the early machine learning times where we were using machines of IBM, only CPU oriented, a big thing were made basically with, of course, this GPU-based computing. And you heard about AlphaGo, AlexNet, and using mostly supervised learning features and also reinforcement learning. And now we are in the era of what we call supercomputers. And these supercomputers, which have specific interconnect, I would say, kind of structures, of course, were a big paradigm shift because they enable at the same time to do unsupervised learning, which is extremely important because you cannot have labelers. And of course, at the end, you have also emergent behaviors, meaning that you can learn things which were not in your data set. When you start building these things, thanks to these emerging capabilities, there's a lot of different things that you can do. It can go from, and I think my colleague was showcasing, and I think we're only scratching the surface today of a lot of possibilities. It goes from content creation, where you can have ID generation. You can write books today, which they are already on Amazon today, by the way, some books which are written by ChatGPT. Of course, the person behind had to prompt nicely the system chapter by chapter to get his chapter done. So there's some work still of creativity about the context that he wanted to build. But then, of course, the whole writing was done. By the way, writing books is not changing so much when you think about it. Many of the books that you see on the web, on internet, you have some authors which are quite famous, but they have other people who write their books, by the way. So they're just, the guys are just giving some kind of interviews about the ideas that they have on their book. And you have some people who are known, which are called ghost writers, who write the book. So ChatGPT, in some sense, for writing books is nothing else than a ghost writer for a person who has all the ideas in his head about how he want to construct, but doesn't want to spend time writing word by word exactly what's going to be there. But this is just a comment that I'm giving here. Of course, I'm sorry, there are, of course, people who are writing their books, but you have a lot of ghost writers basically out there who write basically books for people who don't have time, who are quite famous and have basically some experience and want to tell about their biography of life. But if you go on, you have also copywriting, code writing, generating basically websites, which is extremely important. You define basically some of the big ideas and you write it. Then in terms of visuals and sounds, image generation, this is, as you know, extremely hard. You want to do your PowerPoints, how much time you're going to do to generate and do the picture. Their text to image is very nice to generate your PowerPoints, video generation, voice generation, and game design. And then you have also what we call the content curation analysis. And this goes to text summary, video summary, to transcript, language translation, information clustering, formatting, also basically some extract like information retrieval, web search, Q&A, and also doing some data analytics, forecast, visual analytics. And the other step also, which is I think also having a huge impact in the industry, is basically chatbot, virtual assistant, doing some scheduling, responding to your emails. This is what basically Microsoft now is using with Bing and ChatGPT, text editing, visual editing, doing some data cleansing, code auditing, but also things like robot auto control. So the number of cases that you can solve, and each day, I think you're quite aware, the number of startups which are appearing, having basically apps which are based on APIs on ChatGPT is quite tremendous in how it's done. Now, what I want to do as the last step is talk to you about when you build an LLM on your own, what it takes to do it. There's different steps. So of course you can ask me, why would you build an LLM on your own? Well, there are different features why you'll build on your own. First, of course, you master nearly all the different things that you want. The other is also we're seeing a lot of LLMs which are requested based on what we call on-premise. What I mean by on-premise is that we're seeing a lot of administrations which are not willing to use ChatGPT, because whenever you put your information on ChatGPT, it learns on that, but you're also disclosing some confidential information and also some historical kind of discussions you're having. You don't want to give it away, or you want people to be knowledgeable about that. And so you want to have something on premise. So there's our reasons why there's different, I would say, places where building LLM has become important. Main case, the first one is the data. The more data the model is exposed to, the better it will perform on unseen examples. The model architecture, as I told you, there's a choice in how you build it. GPT architecture is, of course, very known, but as I told you, there are others architectures which are also proven to be very effective in doing the same thing. And then there's the whole process of putting your team to pre-process the data, in which basically you need to clean, prepare the data, and also define what we call a tokenization of it, meaning what is the least element in your language that you consider as your alphabet. Then you do your fine tuning to some specific task. And then you need also to do some evaluation. And this is where basically you put some people behind to assess the performance of your model, re-question, rechange, clean some aspect of your model that were not there. And then you have the deployment, which is also very important on how you deploy it. If you decide to deploy it on the cloud, then there's no compression of the number of parameters of your model. But we're seeing also a lot of people talking about edge LLM, or even pouring LLM on a device. So imagine you have a model with 175 billion parameters that you want to import on your device. How are you going to do it? So of course, techniques are being done right now to compress that kind of model and still have the same performance to be able to be ported in nearly any edge device. Then of course, there's the explainability of your result. This is something on which I think we're not up to it. As you know, a lot of questioning today on these ChatGPT is about, give me your references. Where are you getting this answer from? And on which you want to know the different, like Wikipedia, references related to the statement which was given. The privacy and security also about these LLMs and how they can be cheated on, and the bias and toxicity, which was already shown by my colleague. I want to talk about two initiatives that we did here in the UAE. The first one that we were asked to was to build the largest language model in Arabic, which is this ChatGPT similar, but focused on Arabic and only based on data which is related to Arabic. So the model that we built today has 10 billion parameters and does basically the narrator, chatbot, Q&A, and summarization, and works in a similar manner as ChatGPT, but focused on the Arabic community. And there, it's not easy, because I'm just going to give you an example. There's many things I can tell you, but when you look at data for any language, Chinese, Arabic, whatever, well, it has some specificities. And so typically you need to pre-process the data. There are letters which are quite specific, where you need to define some kind of tokenization. And then basically you start doing the deduplication, the language identification, and the filtering, which is a lot of processes that need to be made, with also some experts who know the language on which you're going to build those things specifically to that. And the thing that we did, which was quite good, is that today Noor that we built is writing article in Etihad News. So the first article that we published based on AI, we were given a statement by the newspaper about COP27, and they asked us, well, give us some highlight about COP27 that not a human would write based on the conference, but basically an AI. And so it was the first article which was published on the press, basically related to Noor, and that was also a big hit. And now we're going also in some discussions to have that in a more weekly manner of having some kind of column in the journal related to what an AI can write as a journalist. And so, just to give you some feature, the kind of things that you do. So this is in Arabic. I don't think you understand, but you write some statement just like Chat GPT. He means tell me things about football, and then you click, and then it writes you text on football, basically in one country, and it gives you some description around that. As a second step, now finish with that. Just to give you a hint about the fact that models being too large does not make sense. And now it's the run around models, which are still performing quite nicely, but basically with less parameters. So, of course, Llama was already one of the models that you're seeing now as a model with very less parameters of Facebook and getting. And we built basically last 2 weeks ago the biggest model in the MENA region with 40 billion parameters, which has basically performance to the GPT-3 like, and provides basically all the things that you see as of today. And here you have a video that I can show you basically of the prompting that we do in the same manner. So and building on exactly on this. So here it just tells you where the state of the art compared to GPT-3, where our Falcon LLM based on the different numbers that we got is going. But basically, you can see here in the video, typically you prompt the machine, you say UAE sets out blue footprint for the next 50 years, and then basically the Falcon 40dB generates you all a text related to that statement that you wanted to have. And of course, we did the same thing, crawling all data that we could get and then process it. Summarization, same thing. You see here, we have a huge text in English, but you can have it, of course, it's multilingual in other languages. And there you put it, and the text, sorry, is going to finish right now. And then you're going to see a summary in one line, but you can ask also in 2 lines, 3 lines. Same things, you can have a conversation. For example, could you recommend me a scientific book? The machine tells you, okay, great, Dune sounds pretty cool. Can you tell me more about it? And then you engage into the discussion. Same thing about what it thinks, how it does, and authors that you think about, and going on. So that tells you also that with the 40 billion parameter model, you can do very nicely. Same thing, you do some translations, multi-language capability that I was saying. You ask other questions, you ask any kind of things, and also going on. So I think you got a view here rapidly of 2 things about this notion of large language models, which is happening, and also some other places where LLM are taking place and being built in the same kind of philosophy. I think I'll stop here because I think I had 2 or 3 minutes questions, and I hope it was clear.
Yeah, it's great sharing. So maybe from audience first, see any questions? So maybe also first question from myself, and as I know, also from your presentations, the ability or the capacity of the model is based on the numbers of data. So is it means like in futures, is it more data then it will have a more mature machine, or any limitations or on its capacities?
So that's a good question. So first of all, as I told you, the capability of models today is based on 3 things: is the size of your data set and the quality. Second, basically, is the time you spend training. So if the longer, it's like if you study longer, you learn more. Okay, you spend more time studying the topic. And third thing is basically the number of parameters. So if you explode the number of parameters, that also. So these 3 features are important. So of course, the more you have data, basically, the more the models are going to be better. However, there's some discussions today in saying that it may happen that at one moment the machines will not need anymore to be fed by data anymore, and will be like us humans, they'll be disconnected because then they will learn. There's an amount of data sufficient on which the
Mm,
machine will start being a human-like machine. So there's some discussions. I don't want to get into that. The second thing also that we're seeing today, which is quite interesting, is that there's a fear that a lot of the content which will be generated in the future will be mostly content generated by machines, which
mm,
means that do you see what I mean? So now we're
yeah.
learning on data done by humans, but at one moment, because now everybody's using ChatGPT to write books, whatever, the whole entire of new books which are going to be appearing are maybe just 2% of human input,
Mm,
98% of things. So this is also some tendency that will maybe incur the fact that useful data will become extremely expensive because a lot of
mm,
the content out there will not be generated by website will not be generated by humans anymore. A lot of things which are written as ads will not be generated by humans. So learning on what's available is not going to be it's going to be very scarce to find humans providing. And you two and me, you will also be reduced in writing because your
mm,
kid you why would you write now today? You will emails, you don't need to write them. You just explain a couple of things, but you will not write a text. So your
mm.
capability of writing will be also reduced. But these are the considerations I don't want to get into. Yeah.
Yeah, that's true. So I see one question from the audience. Candy mentioned about the specific models of one language. So can you share a bit like any do you know other like existing models for like for example Chinese language or other
So,
things?
so Chinese, I'm not aware of. Of course, there are countries. For example, in France, they have a specific model called Pagnol, which is specifically for French. So, of course, in some places, they're building specifically languages for a given. I mean, they're giving large language models for a given language. For Chinese, I'm not aware of.
Mm. But maybe a follow-up questions on it. So if the machine is built on a very specific language, like for example in Chinese or it built on English, what is the major difference except like the language itself?
Yeah. So that's a good question. So when you train on data sets of a given country, meaning in Chinese, for example, the machine will also think or behave or answer in the same kind of setting. So
Mm,
if example you say no problem, I'll ask the English and then translate to Chinese, you will not have the same kind of answering because why do you learn a language today, by the way? You don't learn a language only today because of speaking. There's also a culture behind. I don't know if you
yeah,
understand.
that's true. Yeah.
There's an understanding on how you do because if your objective of just learning a language is just about being able to reproduce word by word, that's not why you learn a language. And I think people will continue learning languages in the future, by the way. These systems are not going to stop it because you don't learn a language just because you want to speak, but you want also to learn the culture and how people talk. Yeah.
Yeah, that's true. So I think last questions. So from the audience, I have an impression that when LLMs are used for assessing and protecting outcomes of the court cases, the results are always confined to be the past. Is there a way to add future?
So that's a good question. So if you look at ChatGPT, roughly you can, if you ask any questions after a certain date, then it the guess doesn't give you. For example, if you ask ChatGPT who won the World Cup in Qatar, you will not have the answer. So in general, yes, you can. So either you need to retrain, or when you are starting to prompt the machine and putting, I would say, some questions and answer, that kind of information, it will add it to itself. And if you tell, well, France or Argentina won the Qatar World Cup, that information will be taken in the prompt, and then it will add features a bit more. Yeah.
Yeah, that's really great. So yeah, thank you so much for your sharing. I think it's really insightful that because nowadays we thought about a lot of ChatGPT, but actually we don't know too much in details like actually what is going on. And I really echo on the points that the language is really related to the culture. So yeah, thank you so much for your sharing, and it's great to have you join us.